Okay, here's today's lesson. Equations and inequalities is the title of the chapter. The majority of the equations and inequalities you've at least seen before. Says the objective, students will solve linear, absolute value, and quadratic equations and inequalities. This is the entire chapter. They'll also investigate the relationship between their graphs and equations, as well as review distance, midpoints, and the graphs of circles. Today we'll probably just knock out this first part. Here's what we're doing. Students will solve linear equations, simple rational equations, and absolute value equations, including identities and inconsistent equations. Okay, solving linear equations. The biggest thing that I want you to recognize with as we're going through this, you've solved linear equations before. You've seen it, been there, done that. But we're going to try to connect linear equations and solving equations with graphs. If you make this connection, you can solve any equation. I don't care if it's linear, absolute value, whatever it is. You can solve any equation with a graphing calculator. And that's the connection we're going to make today. 3x minus 4 equals 8. And again, reminder on how I solve equations. If you already know how to solve these, please completely disregard. If you don't like the way I do it, completely disregard it. Here we go. The way I teach this is to move a term. There's 3 terms here. To move it from one side of the equal sign to the other. Any term. If it's a negative, make it a positive. If it's a positive, make it a negative. Our main goal when solving any equation is to isolate x, to get it by itself. So here we go. In order to get x by itself, we got to get rid of a 3 and a 4. To get rid of minus 4, we're coming to the other side by doing plus 4. Mark it out. I now have 3 x's on the left side. Bring down my equal sign. 8 plus 4 is 12. Last step, in order to get x by itself, since they're being multiplied, we divide by 3. And we get x equals 4. I'm hoping that is incredibly easy. You've seen it so many times that you really didn't need to see that. Now I do want to show you the connection between that and a graphing calculator, or a graph. Look at each side here, and again keep in mind what the answer was there, x equals 4. And what I'm about to show you, again, could be valuable to you, not necessarily on this one, but on some of the more advanced graphing calculators, or on the more advanced equations. 3x minus 4, you've graphed those before. We're about to graph them again. Those are lines, okay? This 3x minus 4 is a line that has a, what? What's the 3 represent? Slope. And a negative 4, thank you, y-intercept. Slope-intercept form. This is a line with a slope of 3, y-intercept of 4. How do you graph 8? Does anybody know what that line looks like? I'll show you. 3x minus 4. And come down to the second one, and we're graphing 8. Okay, we want to know where those two things are equal. We hit graph, we have that 3x minus 4, and the other one's not going to fit because I'm not zoom standard. Let me go zoom standard. There's 3x minus 4, there's 8. That's a horizontal line. Now we're looking for where are those two things equal, right there, where they cross. Okay, so any equation, like I said, any equation from here on out can be solved with graphing. Graph the two sides to find out where they're equal, look to see where they cross, and we actually have a function here under second calc that says intersect. We go to 5, enter. It'll ask for first curve and second curve. That's just telling it which two lines or which two curves are the ones you're talking about. Most of the time you'll only have 2 graphs, so it'll be enter, enter. You don't really have to guess. You can if you'd like. I don't know if the calculator's just trying to make it fun for you. But when it says guess, you can scroll over it. Here is the purpose of guess. Sometimes you'll have 2 answers. And with a guess, you're telling it, okay, the one that I'm looking for is about 3 or 4. It doesn't really matter that you guess. Hit enter. Look, x equals 4. It'll give you, and again, we knew that, but it will give you the answer there. Now, what is the 8? Y equals 8. If you plugged in 4 on each side, 12 minus 4, you get 8 equals 8. Okay, that's what you would get if you did plug it in. That's too small. Again, we got 2 lines. 1/2 x minus 6 and 3/4 x minus 9. First step, let's combine all of our like terms. Let's get this 1/2 x over here with a 3/4 x. Since it's a positive, we'll change it to a minus 1/2 x. At the same time, let's mark that out. At the same time, minus 9 comes over here with a minus 6 and turns into plus 9. If it moves across the equal sign, make sure that if it's a minus, change it to a plus. If it's a plus, change it to minus. Negative 6 and 9 gives you a 3. Okay, let's see how good we are with fractions. Well, we can subtract two fractions, common denominator. We have a 4 and a 2. Let's change them both to a 4 without writing it down. Okay, we already have 3 4s. In order to get a 4 here, we're multiplying by 2, top and bottom. 1 turns into 2, 2 turns into 4. This is now 2 fourths. You now have 3 fourths minus 2 fourths, which is 1 fourth. So I move my numbers to the left and move my x's to the right. Next step, I got to get rid of that 1 fourth. Logan, since they're being multiplied, how do I move my 1 fourth to the other side? Divide by 1 fourth. Does anybody know how to divide by 1 fourth? To divide two fractions, you flip the second and multiply. So divided by 1 fourth turns into times 4 over 1. Mark it out, x is 12. Again, let's say you get on your ACT and you've got that problem. Just type both equations in. 1/2 x, and I would put it in parentheses just to be safe. 1/2 x minus 6. Enter. 3/4 x minus 9. And if you don't know to put the fraction bar, it's divided by 3/4 x minus 9. Graph. It's not going to fit on my graph because this goes up to 10. So let me show you this. If it's not fitting, you can do zoom out. You can, what I like to do better is change my window, because look, it was nearly about to cross. Okay, if I move my window out, this goes up to 10. If I move it out to about 15, I think I'm going to get the crossing point. So go to window. You've got x minimum, x maximum. That's how far left and right your graph goes. This is how far up and down your graph goes. Let's go down and change my x max to 15, and it should fit now. See, now I've got from negative 10 to 15, and you do see the intersecting point right here. We go to second calc. We are looking for the intersection, which is 5. First curve, enter. Second curve, down there, enter. It doesn't matter if that's only 2. Again, you can just, honestly, if you only have 2 curves on here, to find the intersection point, you can just quickly hit enter, 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 and it's going to give you the answer. X equals 12. Any questions on how to do that? Okay, next problem. Also linear. The reason I know it's linear is there's no x squareds, and when you multiply this stuff out, there's still no x squareds. First step, if you have parentheses, let's get rid of them. 3 times 4, 3 times 1. That's 12x minus 3. Distributive property equals. It's very tempting for some reason to do 4 minus 6 here. Make sure you remove parentheses first. The 4 stays. Negative 6 times x is negative 6x. Negative 6 times negative 3 is a positive 18. And I'm flying through this. You've done linear equations once or twice before. I'm getting all my x's on one side. Here's a minus 6x. I can combine with these 12. So minus 6 turns into plus 6. Mark it out. 18's already over here. Minus 3. Let's move it over here with the 18 by doing plus 3. These 4 are already on the right side. Do not change their signs. Leave it a plus 4. I now have a total of 18x equals 25. That's ugly. To get rid of the 18, we're going to divide by 18. Try to reduce it. If it does not reduce, please leave that. Instead of writing it as a decimal, 25/18 is an exact answer. As soon as you change that to a decimal, it's no longer exact. Here's the graph. Got a screenshot of it. If you actually did 25 divided by 18, you're going to get 1.38 repeating. But a lot of people say, but there's 9 at the end. Yes, that's where they rounded it up. It was 8 repeating, and then they stopped, rounded that last number up to a 9. I promise, it's 8 repeating. Okay. And if you typed in 25 divided by 18, that is what you would get. That's the only problem with using the calculator. You're going to get a decimal answer for your intersection instead of the whole number. Just make sure you know how to do it both ways. Okay, with what we've been talking about, you have 3 different types of equations. Now, you talked about systems in previous years, and this kind of goes right along with systems. Every problem that we've worked thus far has been this type. The system is independent and consistent. Okay? Meaning that you have one solution. It crosses, when you do the left side equals the right side, it crosses at a single point. Okay? That means it has an answer. Then you have this scenario. Where are the two lines equal? Where is the left side equal to the right side? Nowhere. So that system is what's called inconsistent. The word consistent means you have an answer. So therefore the word inconsistent means you do not have an answer. So therefore no solution. It does not cross. There's no answers. Now be leery about this. Now reminder, if you're talking about systems, this is where your slopes are the same. You have equal slopes. If the slopes are slightly different, they're going to cross somewhere. Okay? So just because they don't cross on your calculator screen does not mean they're not going to cross, so be extremely cautious of that. But that's an inconsistent. Anytime you have no solution, that's called an inconsistent set of equations there. That's clear. And the last scenario, looks like you have one line. You don't. You have two lines right on top of each other. This system is what's called dependent. Okay, a while ago we had consistent, independent. Consistent means you have a solution. Independent means you have one solution. The word dependent, okay, independent means not dependent. So independent is one solution. Dependent is infinite solutions. Okay, you got one line, you got another line. Where do they cross? They cross everywhere. Okay, that means no matter what x value you plug into that system, it's going to make it equal. What's an example of one? Here you go. X plus x equals 2x. If you solve that equation, plug in anything. 3 plus 3 equals 2 times 3. 4 plus 4 equals 2 times 4. No matter what you plug in, it's true for any number. So that would be an example of a dependent equation. Determine whether the equation, and they give you some ugly equation, is an identity, which when it says identity, that would be dependent. An identity is something that is true for all. Dependent. True for all values. Inconsistent equation means there's no solution. And conditional would be one solution. That's the three things we just went over. That's just another way of saying it. Conditional has one solution, identity, all solutions, and inconsistent, no solutions. So how are we going to do this? One method, you can graph it. I'll go ahead and tell you that's not error proof. You might run across a few errors if you just graph it. Let's get rid of parentheses. 3 parentheses would be 3x minus 3. Negative 2x times parentheses would be negative 8x plus 2x squared. Let's also get rid of parentheses on the other side. 2x times x is 2x squared. 2x times negative 3 is negative 6x. And 1 times x is x. And 1 times negative 3 is negative 3. Clean up. A lot of people say, well, we haven't done quadratic. We've done quadratic equations, not really. Kind of touched on them last chapter. But this is not quadratic. Because look what happens. When you move 2x squared over here by doing minus 2x squared, they're going anyway. They cancel each other out. But let's clean these up. Let's combine some like terms. 3x minus 8x is negative 5x. And then you have the minus 3 over here. On the other side, you have negative 6x plus x, which is negative 5x minus 3. Check that out. Do you need to combine x's? Well, if you want to, you can. If you move negative 5x over here, they cancel out anyway. It leaves with negative 3 equals negative 3. And if you wanted to move the negative 3 over here as well, that's fine. You'll end up with 0 equals 0. It's kind of pointless. Look at all three of those. The left side and the right side are the same thing. No matter what value of x you plug in, you're going to get a true statement, correct? If you plug in 1, I think you're going to get the same thing on each side. Plug in 2, you're going to get the same thing on each side. That would be an identity. That would be a dependent system. No matter what you plug in, it's true for all values. That's an identity. If you don't believe me, come up here, plug in 5. Plug in 6. Plug it into both sides, you'll get equal statements. Any questions? Do we have a rational equation? You have a fraction, you've got y's in the fraction. We will do rational equations again later on. We're doing some basic, very simple rational equations in the second chapter, and then we'll hit the tougher ones later on. The reason that they're giving you rational along with linear is because they kind of go together sometimes. By the way, remember those domain restrictions? Before you even start this problem, write this down. Remind yourself, well, if I solve this and I get 3 for an answer, it can't be 3. Remember black hole? If you plug in 3 for y, you get 3 minus 3 on bottom, which is 0. The bottom of a fraction, from this original, the bottom of the fraction cannot be 0, so let's exclude 3 before we even get started. Okay, next step. And this actually works for that problem I gave you a while ago that had fractions in it. This same method would work for it. Step number 1, find a common denominator. That's a 1. Find a common denominator. What could I turn all 3 bottoms into? Well, I think I could turn them all into y minus 3. Pretty easy. Just multiply top and bottom by y minus 3. So common denominator, I'm going to come over here to the side and list it. Common denominator, y minus 3. This is not the only method for solving this, but it's the quickest. Next step, we're going to take this equation, blow it up a little bit, and we're going to multiply everything. I'm putting the whole equation in parentheses. I'm multiplying everything by the common denominator. And if you want to think of these bottoms as being in parentheses, they are. Allie, when I multiply y minus 3 times my first term, what happens? Careful. Do I actually have to multiply them? Look at top and bottom. What's going to happen with those y minus 3's? They cancel. Good. I can mark them out, and I'm left with y. Plus, when I multiply y minus 3 times 3 over 1, really I don't have to worry about the bottoms. 3 times y minus 3 would be 3y minus 9. Any questions there? Colby, when I multiply y minus 3 times my last term, what happens? And you're left with, good. If you do it correctly, when you multiply an entire equation by a common denominator, you have no more fractions at all. Okay? These two things are identical with this one exception. Okay? You've got to be careful because here it looks like y could possibly be 3. But from my previous problem, I know that it can't be. So here we go. Combine like terms. Y plus 3y gives me 4y. Let's move my minus 9 to the right side by doing plus 9. I get 12. Divide by 4 and we get y equals 3. Here's the thing. We have an issue. We have conflicts. To begin with, we said that y cannot be 3. Now we've got that y is equal to 3. So what do? We throw that out. Y cannot be 3. Okay, so what is y? Non-existent. No solution. Since the only solution that you obtained was one that we could not use. Okay, now let's go back and talk calculator. While you're finished writing that down, I'll try to type this in. It is inconsistent. And this is not fun to type in. So watch how I do this. I usually do, around a fraction, I'll do a huge parentheses around the whole fraction. Then I'll do by the top, won't really have a parentheses since it's just y. I don't have a y button, so I'm just using x as my variable. So I'm doing x divided by, and I'll put parentheses around the top and bottom as well just to be extra cautious. X minus 3. So I've got one parenthesis around the fraction, one parenthesis if I needed it around the top, one around the bottom. And then plus 3. That's the left side of the equal sign. Right side of the equal sign, I've got 3 divided by x minus 3. And you really didn't need, since this is the only thing on the right side, really didn't need a parentheses around the whole fraction, but I did it anyway. Graph. You get a weird looking graph. And where's it cross? We're kind of getting ahead of ourselves with this one. here, guys, is a what's called an asymptote line. This is not part of your graph. Anytime you see a line shoot straight down like this and the graph's coming like this, what that is actually doing is your graph comes along down through here and it starts slanting down. Your graph gets closer and closer and closer to this line, but it never crosses it. Now you can try second calc. Let's say that you think, for some reason, you just think that you saw it cross right in here, somewhere around 2.5 maybe, because it can't be 3. X can't be 3. So let's just say that I think it's going to cross somewhere around 2.5. So my first curve, enter, second curve, enter. My guess is actually already at 2.5. No sign change. Pretty much tells you, what does that error mean? There's no solution. Okay, you can just go with that. Okay, no solution there. So your calculator can also tell you that. Take one more of these. Common denominator is not quite as easy here, but think back to that first chapter. Why did we go over the whole rational equations, or excuse me, rational expressions, common denominators? This was part of the reason. Give you a second to get ahead of me. Try to write this down and try to find you a common denominator here. First step is to factor, by the way. Okay, I've got it factored. Here's what you ask yourself. What's missing here that I have over here? X plus 1 maybe. What's missing here that I have other places? X minus 1. What's missing here? Nothing. What's my common denominator? Common denominator would be therefore be X plus 1 times X minus 1. What could you change all three bottoms into? You could change it into that. Okay. Let me see if I can move that over some. I need some space. Once you have your common denominator, multiply the entire equation by that common denominator. Stuff's canceling. Yes. Because here's the way to think of it. When you multiply by the common denominator is pretty much a combination of all the bottoms, correct? When you multiply by the common denominator, all the bottoms will end up canceling with parts of that common denominator. Huh? Yes. Now, could I? I told you a while ago there's another way of working this. Once I find the common denominator, could I change all the bottoms to that common denominator? Yes. Okay. And once you have, let me show you something. X over 4 plus 3 over 4 equals 7 over 4. Here's the other method that, if you'd rather use this, is fine. Let's say that you're solving a rational equation. You've changed all the bottoms to be the same. Do the bottoms matter anymore? Think about that. X over 4 plus 3 over 4 equals 7 over 4. Ignore the bottoms. X plus 3 equals 7. What goes in the place of X there? 4, right? 4 plus 3 is 7. If you wanted to, you could actually change these. Find the common denominator, multiply top and bottom by X plus 1, multiply top and bottom by X minus 1. Here it's already that. You could do that and then just completely dump the 3 bottoms. You can do it that way as well. You can do it either method you want to. Okay? Biggest thing to remember, and this is what I always forget, X cannot equal -1 or +1. -1 and +1 will make the bottoms equal to 0. And I always forget that. Multiply everything by common denominator. Here the X minus 1s will cancel and leave you with X plus 1 over 1. Everybody understand that? When you multiply the common denominator by the second term, the X plus 1s will cancel and leave you with minus X minus 1. Notice I've left that X minus 1 in parentheses. Same reason from chapter 1. We're subtracting the whole thing, not just part of it. Equals. When I multiply the common denominator by the third term, they will both cancel and leave me with just 2. X minus X is gone. 1 minus 1, or 1 minus -1 gives you 2. So you're left with 2 is equal to 2. Weird. When is that true? Always. Okay, so this would be a consistent dependent system, which is also known as an identity. This is always true. So what's an answer? Everything. Plug in 5. You get 1/4 minus 1/6 equals 2 over 24. 1/12. If you subtract that out, I promise it's true. Okay. Now let's go with Abby's question here. Let me just show you, and if this seems easier to you, do it this method, please. I wasn't even going to show you, but I started thinking about it. This might make more sense to some people. Common denominator, multiply top and bottom by x plus 1. Well, let me rewrite that. And I'm leaving space so that I can multiply. Okay. Common denominator is this stuff. Let's change all three bottoms to where they're the same. Multiply top and bottom by x plus 1. This is your other method. Multiply top and bottom by x minus 1. Now that all three bottoms are the same, you can actually forget about them completely. Again, the reason being is if you've got x over 4 plus 3 over 4 equals 7 over 4, the bottoms don't matter. The bottoms are all the same. Okay? So dump them, forget about them, and you actually get the exact same thing. X plus 1 minus x minus 1 equals 2. Same thing. Okay? Use the method that makes more sense to you. That's enough of those. Let's work this one. Because a common denominator will not be fun on this. If you would like to, a common denominator could be found by doing 2.4 plus or times 5.9 times 8.2. But here's what I want to do. I want to remind you that these equations, notice the solution there, not a pretty solution. These equations can be solved using your graphing calculators. If I ran up on one this nasty looking, I'd probably use my graphing calculator. But we really don't want decimal answers. Well, you've really already got decimals in the problems. So there's a good possibility that you're going to get a decimal answer anyway. Unless you want to, for some reason, multiply top and bottom by 10, and you could actually get rid of these decimals, 70 over 24. 30 over 59 and 10 over 82. That way you don't have to deal with decimals. That's fine. But again, what I would do is I type in the left side, I type in the right side. Notice the right side is just a number. It's about 1/8. That's the reason you have this horizontal line here. The left side is actually, it's an odd looking equation there. Here's your solution. You get an intersection at negative 0.1325223. You've got it solved, okay? That's what you're looking for. Just use that intersect function. Absolute value functions, probably be the last thing we do today. I do need you to know this. Well, first off, you need to know what an absolute value is if you don't already. Absolute value -3, absolute value +3. What does absolute value mean? Does anybody know what the absolute value -3 is? +3, good. Does anybody know what the absolute value +3 is? 3. Absolute value is a distance. The distance from here to Scottsboro, what would you say, about 12 miles? So you drive from here to Scottsboro, or 12 miles. You drive from Scottsboro back to here, is that -12 miles? No, it's still 12 miles, okay? Distance is positive. Okay, anytime you're talking distance, you're talking a positive value. So that's one reason we have absolute value is anytime you have a distance, you're even though you might be subtracting, put these bars around it, it's positive, okay, regardless. The technical definition of what absolute value is how far a number is on a number line from 0. Not a bad idea to know that. or just, it's not going to be on your test, but we'll talk about that again later on. Actually, we might talk about it since we got a little extra time right here. Absolute value is how far a number is from 0 on a number line. The absolute value of -3, how far is -3 from 0? 3. How far is 3 from 0? 3. Okay, that's what absolute value is. It makes things positive. Now, what if I've got, let me show you this. Clear? The absolute value of, let's say, something like 2x minus 3. What does that graph look like? And why? If you graph 2x minus 3, that's a graph that has a y-intercept of -3, has a slope rise 2, run 1. It looks something like that. That's the graph of 2x minus 3. Now, what's the graph of the absolute value of 2x minus 3 look like? Very similar. This will be the same, and then it'll do this. Why? It can't be negative. What this absolute value bar, again, you've always, hopefully, you've always seen these absolute value graphs to be V-shaped. Now, why are they V-shaped? Because everything that used to be negative is now positive. It took this negative stuff down here and it flipped it up and it made it positive. What used to be down here at -1 was now up here at +1. What used to be down here at -3 is now up here at +3. Everything negative is positive. Okay? What happens if you put the absolute value, see if that makes sense. What happens if you put the absolute value around a parabola? Let's do x squared plus 5x plus 6. The parabola x squared plus 5x plus 6 looks like this. It crosses at -2 and -3. There's the parabola x squared plus 5x plus 6. Didn't have to know that. We're fixing to talk about it actually. Probably tomorrow or the next day. So what happens when you put the absolute value around it? This little hump right here that's negative, we'll flip it up to here. And it would look kind of like that. That makes sense why. It was negative, make it positive. So it's kind of like a W shape then. Okay? So that's what absolute value bars do. So my biggest thing, if you have the absolute value of something linear, it's going to be a V shape. Please know that you've got V shapes on these. The reason I want you to know that is when you solve these. The absolute value of x minus 5 equals 4. Now I'm going to first solve it by hand, and then I'll show you how to use a calculator to do the same thing, because you might not think that you have an absolute value button on the calculator. Okay, I'll show you where that is actually located. Absolute value of x minus 5 equals 4. Let's solve this one instead. The absolute value of smiley face is equal to 4. Brett, if the absolute value of smiley face is 4, what could smiley face be? 4. Thank you. 2 answers. Everybody understand that? If the absolute value of something is 4, that means that that something could either be 4 or it could be -4. That's all you need to know to solve this. I'll say that one more time as I'm writing this down. If the absolute value of something is 4, then that something could be 4, or that something could be -4. That's all you need to know to solve these absolute value equations. The absolute value of something is going to make it positive. Okay? If this something is 4, that makes it a true statement. If this something is -4, it makes it a true statement. Solve each, you're done. So x could either be, move -5 over by doing +5, 9. Or x could be, move -5 over by doing +5, you get 1. Plug it in and check it. 9 minus 5 is 4. The absolute value of that is 4. 1 minus 5 is -4. The absolute value of that also 4. True statement. Why does it have 2 answers? Let's go back graphically. I want you to connect every one of these equations with a graph. The absolute value of x minus 5 looks like this. You've got, let's see, x minus 5 would be something, y-intercept of 5. It's going to be positive here, and then the other negative part would flip it up positive. It's going to be a V shape. That's the absolute value of x minus 5. That's a bad V. But what does 4 look like? Anybody? What type of line? Horizontal line. How many solutions will it have? 2. And those solutions would be at 1 and at 9. Yes, sir. Sure. Just watch the video for the rest of it. On your calculator, you might want to see this before you leave. Where do you find, if you wanted to graph those two, where do you find the absolute value button at? It's located, you have to go into the catalog. Okay? Above the 0, you have the word catalog. You would have to do second catalog. It is the very first thing, ABS. It's the very first thing in the catalog. So you got the absolute value of x minus 5. There's the left side, and I've graphed it out of order. There's 4. Here's the two graphs. There's y equals 4. There's the absolute value of x minus 5. Second calc, you're good now. Second calc, go to intersect. My first curve, enter. Second curve, enter. Now here's where you would need to guess. Do I want this answer or do I want this answer? If I want this answer, I would guess somewhere right in here, somewhere around 2, 1 or 2. If I wanted this answer over here, watch me change my guess. This answer is somewhere around 9 or 10. Let's type in 10 as my guess. Hit enter, and that's going to give you that answer. So you would actually have to go do this twice to find both answers. Okay, one answer is 9. You can go through it again to find the other answer. Last problem. Before you start, please isolate the absolute value. Minus 6 and 2, move them to the other side. That gives you the absolute value of x plus 8. Let's move them in our head. Minus 6 turns into plus 6. Times 2 turns into divided by 2, and then you now have 3. Again, mark this out by doing plus 6. Now you have 6 over there. Since this is being multiplied by this whole thing, mark it out by dividing by 2, and you get 6 divided by 2, which is 3. And you're going to solve that the same way. I'm not going to go through the steps of solving that, but you would solve that identical. I do want to caution you on something, though. Let's say this was my problem. Let's use some common sense, please. The absolute value of x plus 8 equals negative 7. Jordan, tell me one more time. What does absolute value bars do? Makes things positive. Can you take the absolute value of anything? These are so fast if you know how to do them. If you take the absolute value of anything, will you ever get a negative 7? Before you even start, you stop there and you put no solution. It can't happen. Okay? Now, if there was a negative out front here, that's possible. You would have to divide by that negative, make it positive. That is possible. But as it is, absolute value can never be a negative. Any questions?